Let's not do the warm-up for the sake of time today. So, again, you're going to solve for that point of intersection. So down here we have 3 equations, 3 variables. Yes? So you have to look at the equations, look at them, and decide what's the easiest to start with. Before you just jump in, there might be an easier method. Now remember, your goal, I'm going to write it up here. Your goal is an ordered triple, because you got X, Y, and Z. That's what you need. Okay, you need X, Y, and Z. Now, the thing, oh, first of all, don't write too big. The thing of this is just be meticulous. You know what meticulous means?
Yes.
Watch your signs. Watch that you're writing, you're multiplying everything correct. Because it's easy to make a mistake. Now, I like to number my equations 1, 2, and 3 so I can keep track of what I'm working with. Your first job is to eliminate one variable from 2 of the equations. So let's look at this. Maybe it would be easy to eliminate what to start with? Z from 2 and 3. See how Z could go away easily? Now, I'm going to rewrite them. I know you don't want to do it. It's a pain. But I think it helps keep you straight. I'm going to rewrite them. I don't have to multiply through by anything because I can get rid of Z as they are right now. Draw a line under there. Cross off Z. So your goal is always to start with 2 equations and eliminate one of the variables. So then you add down. So we got 2x plus 2y equals 2. Can I make that prettier?
Negative.
What can I get rid of on all of these?
2.
A 2. I can divide it all by 2, and it's just going to be a nice, pretty, simple equation. I'm going to label that A. And I'll show you why in a minute. All right. I eliminated Z from 2 of them. I got to eliminate, yeah, Trevor.
So could you start off and multiply both of those equations by, if you multiply them both by 2, then could you get rid of the y's and the z's?
You're nuts.
You might be able to do that.
What do you say?
You might be able to do that.
What do you say?
It's very smart. Okay, let's flip. All right, now, I'm going to now, just for the heck of it, I'm going to take 1 and 2 and eliminate Z. Okay, no, we did 2 and 3.
Oh.
So let's look at what I have to multiply 1 by and 2 by, different numbers, to eliminate Z. Let's take it up to 30, right? If I make this 30Z and this negative 30Z, I can get rid of Z, correct? So I'm going to multiply the top one by 5 and the bottom one by what? How do I need 6? So let's rewrite 1 and 2 now. I'm going to multiply 1 through by 5. I get 10x minus 5y plus 30z equals negative 20. Now I'm going to multiply number 2 by 6. 36x plus 24y minus 30z equals negative 42. Again, my goal is to get rid of z here as well. So that works. I got rid of z. Add down. It looks yucky, but it's going to work. And I'm going to label this B. Now I have 2 new equations I'm working with, A and B. Okay. These both have x and y in them, correct?
Yes.
Remember, my goal is to get down to one variable. So this is really easy to multiply by negative 46 or negative 19. It doesn't matter. Okay. So I'm going to multiply this by, let's say, negative 19. And I'm going to rewrite it over here. So negative 19x plus negative 19y equals negative 19. Oh, and I can get rid of y. This equals, something happened here. I know, something happened. And then you take the x and the y and plug into any of your equations. I just did it into number 1. You can plug it into any of them. Plug into number 1. And this is what you get. You get 2 times negative 3 minus 4 plus 6z equals negative 4. And when you solve for z, you get 1.
Wow. Why is this so long? So anti.
So let's review. Yeah, first, I told you it's tedious. First you just look and see if you can get rid of one of them easily. You might have to multiply through by something. Then, shh, we're not done yet. Then there's a freaking backside.
One question, hopefully.
Oh well. So anyway, we'll just start on the backside. First you start by eliminating 1, and then you eliminate that same variable from 2 other equations, okay? Backside. Ladies and gentlemen, shh. These are quick. We got a solution here. This was a point. Now we got to look at what happens when you have infinitely many and no solutions. It's quick and easy. So number 1, 2, and 3 here. Hey, let's look at 1 and 2. If I multiply 1 through by negative 3, I'm going to get rid of, let's say, x. Let's just see what happens. So I'm going to rewrite 1 as negative 3x plus negative 3y plus positive 3z equals negative 6. And then I'm going to write 2 down without having to multiply by anything. Oh, look what happens. This is gone, this is gone, this is gone. But this is 0. What?
So it's not a solution?
It's never true, ever. So there is no solution here when this happens.
I hope I'm
Now, some of you may be saying, yeah, but what if I choose 2 different equations? Or some of you just don't care. But so what I did as your ever faithful teacher, I worked them all out just to make sure you end up with the same thing, and you do. I took each equation. So we're not going to do that, but I didn't trust it either. So, okay. 1, 2, and 3. Let's see what happens here. Shh. Hey, look at 1 and 2. I can get rid of y real easy, correct? So let's start with that and see what happens. You get, this goes away, you get 2x plus 2z equals 12. Let's make it pretty. What can I divide everything by? 2. So I get x plus z equals 6. So this is my new equation here.
That's where we started.
A. Now let's do 2 and 3. Can I eliminate y here as well? So I don't really need to do anything. I just need to write them over and see what happens. Does somebody see it already? This goes away. 5x plus 5z equals 30. Oh. Make it pretty. Divide by 5. Look at that. What do you notice about A and B? They're the same, which means it's going to be one of those instances where there's what? Infinitely many. Infinitely many. Yeah, they all intersect at one line.
Oh, it's just the
Yes.
Couldn't you just like multiply the first one through by 4 and notice they're all the same? And then
Oh, you could, and see that those are the same?
yeah.
Yeah, you could do that too.
Wait, what?
But it's so much more fun to eliminate, Allie.
That's what I did. The first and the third and
She noticed if you multiply this through by 4, you see they're the same. That works too. Okay? All right, so look. Hey, look at this one. So make sure you leave room.
Shoot.
Shoot.
Okay? You got to do these. You got to try them. Shh. Etiquette. You guys are like, man, it's 6th hour. I warned you. Okay. At a carry-out pizza restaurant, an order of 3 slices of pizza, 4 breadsticks, and 2 juice drinks cost $13.35. Wait. Hold the horses. There's an equation right there, isn't there? If pizza is X, breadsticks is Y, and juice drinks are Z, there's an equation right there.
But why would you buy 3 slices of
Oh, just go with it, okay? First equation, 3X plus 4Y plus 2Z is $13.35. There's my first equation right there in that first sentence. A second order of 5 slices of pizza, 2 breadsticks, and 3 juice drinks cost $19.50. There's my second equation. Jess. I can't hear you.
We don't have to like get an answer by graphing.
No. No.
Eventually.
No. We're never going to do that in this
Is
class.
this able to do on a calculator?
In count.
Haven't tried it.
Can we do this in count?
Don't know.
More than one. That's not.
There's equation 2. Now we have equation 3. If 4 breadsticks and a juice drink cost 30 cents more than a slice of pizza, what is the cost of each item? Okay, so I got 4 breadsticks plus a juice drink. This side is 30 cents more than a piece of pizza.
Is that a third equation?
Yeah, but can I use it like that? I got to move it around so it's in the right form. So I got to subtract x from both sides to get my third equation. So I'm going to write it as negative x so that the variables are lined up. And then I'm just going to cross that off. Now, I got to start the work. What do you want to eliminate first?
4y.
4y I think would be the easiest. You can multiply this one or this one through by a negative. Doesn't matter.
Negative 1.
Okay, let's do 3 here. Okay, so 1, I'm just going to leave the same. And then I'm going to multiply 3 through by a negative. Okay? 3 now becomes x minus 4y minus z equals negative 30 cents. The y's go away. 4x plus z equals 1305. So that's my A, my new equation. So now I got to take 2 of the other equations and eliminate y.
You could do,
These 2?
yeah.
Let's just do 1 and 2. We'll multiply 2 by negative 2. Yes?
Yes.
So I'm going to rewrite 1. That's staying the same. I'm going to multiply 2 through by negative 2. So I get negative 10x plus negative 4y plus negative 6z equals what? Negative 39. I don't want to make a mistake on that. Yeah, it's got to be negative 39. Cross those off. But you have to do it again because you need another equation that doesn't have y. So you only have 1 here.
Oh.
You need a second one so that you can eliminate that second variable. Negative 7x minus 4z. I don't know what that is. Somebody tell me. Because I did it different than what I did here.
25.
Negative 25.65. Okay, this is my b. Now look at these two. What should we do?
Multiply it by 4.
Maybe this by 4? I'm going to rewrite this one up here, and I'm going to multiply by 4. That makes sense. Multiply everything by 4. I get 16x plus 4z, 5220. Is that what that equals? Am I right? Yeah? Almost done. If we did it right, this is always like the drum roll part.
9z.
I don't know what that equals. Somebody tell me. My head hurts.
Wait, 9z. What are you talking about?
Whoa, wait, what's that say?
9x. What is this? Somebody tell me.
Oh, that's negative something?
26 what?
5, I think. Somebody double check.
Somebody do the math for me there. I don't know what it is.
26.55.
Oh,
26.5.
And then when you divide, x should be 295,
Why
correct?
is it 26.5?
I don't know. I asked somebody to do it.
Somebody
Wait.
check.
Yeah, it's wrong.
It's right.
It's
It's right.
Zach had screwed up.
I forgot what we're trying to find.
Okay. That happens. But that's why you look up here and you say, oh, look, the x is the pizza cost.
Wait, there's more though.
Pizza.
You can't do it in 12 minutes. Trust 295.
Okay. Now it's real easy. Let's find an easy play. Let's do this for z. Shh. Plug it into here and find z. So you take this, plug it into here, and when you do that, you get z is $1.25. And what was that? What did we write that as up here?
Juice.
Juice. That's your juice. And then y, which is your breadsticks, when you plug it into any of these equations, you plug x and z in, you're going to find out that y is 50 cents for the bread. Juice is very expensive. Bread is cheap to make.
now if it's a menu next.
Yeah.
Wasn't that fun?